In this circuit we want to find the voltage drop Vx across this 8 ohms resistor. So we will apply a node voltage method to do that. We can see that there's a super node here. This one is a super node. There is a that's a dependent voltage source, current dependent voltage source. So this is the super node. So let's say this is the ground voltage, so that's 0, and if that is the ground, this is plus Vx, so the voltage here at this node will be minus Vx, and at this side the voltage will be minus Vx, and then another 4Ix drop, so minus 4Ix, that will be the voltage drop here. So we want to write now the KCL for this super node. We can see that we'll write in terms of Vx. So if we want to write the current as outgoing, Ix is entering, but we will write it like this. So minus Vx minus 4Ix minus 0 divided by 2, that's the outgoing current, plus 6 amps is outgoing, plus 4, this 4 amps is outgoing. These two are constant current source, and then again minus Vx over 8 equals to 0. So minus Vx minus 0, that will be the outgoing current. That's the equation there. So we can multiply both sides by 8, so that will be minus 4 Vx, then minus 16 Ix, plus this will be 8, 6 plus 4 is 10, so 80, and then finally minus Vx, so that's 0. So minus 5 Vx minus 16 Ix equals to minus 80, or we can write it 5 Vx plus 16 Ix equals to 80. So that's one equation. So we want to find Vx. So what we will do, we can write Ix in terms of Vx. So this current is actually Ix, this one. This current is Ix. So we can write minus Vx minus 4Ix divided by 2 equals to Ix. So that gives minus Vx minus 4Ix equals to 2Ix. That will become minus Vx. Sorry, this current is actually minus Ix. So basically Ix is going in that direction. So Ix will be, I will actually rewrite this so that there is no ambiguity. So Ix is going from ground to in this direction basically. So Ix will be 0, which is the ground potential, minus the potential of this point, which is minus Vx minus 4Ix, and then divided by 2. So Ix equals to Vx plus 4Ix divided by 2. So sorry, this one will be now 2Ix equals to Vx plus 4Ix. So minus 2Ix equals to Vx, or Ix equals to minus Vx over 2. So this is what, so we will substitute Ix in this equation, which is equation 1. We will write Vx plus 16 times minus Vx over 2 equals to 80. So that gives us 5, sorry, this is not 5x, this was 5Vx, sorry. So 5Vx minus 8Vx equals to 80, which is minus 3Vx equals to 80, or Vx equals to minus 80 over 3, which is minus 26.6666 volts. That's the voltage Vx. So we have solved this using node voltage method, and since there was a supernode, this is the easiest way to solve it, because there is a supernode and there is only one nodal equation, and then there were two unknowns, but one unknown could be written as a so two unknowns, there was another equation, because just from Ohm's law using this one. So yeah, this was pretty easy one using this method.